Hey, my name is Jeremy Snyder, and welcome to API Days Australia 2024. I'm delighted to be with you today talking about a very important subject, especially as we are here in 2024. That topic is AI, but specifically the impact of AI on APIs and API security in particular. That's going to be the focus of today's conversation for the next 20 to 25 minutes. Hope you find it interesting. The slides are available already on the slide share, and looking forward to receiving any questions or anything like that. Just a little bit about me to get started. I've spent the last 27-ish years or so in IT, cybersecurity, cloud related technologies, basically been working on applications and infrastructure my entire career. You can see a little bit of some of the companies that I've worked with over time. And currently, I work with a startup called FireTail. I'm one of the co-founders there. I work on the business side of FireTail. We do API security, and so that is the reason for my focus on this topic today. So, the agenda for today, we're going to talk about the double edged sword, why there is no AI without APIs, and why there's both a positive and a negative impact of AI on API security. We're going to talk out through some of the pros and the cons, some of the use cases on both the defense side and on the attacking side, a little bit about threat modeling. And if this were live, I would be taking questions. But to kind of set the stage for today's conversation, I want to talk about some of the trends that I've observed over my career in cybersecurity and specifically around the security concerns of emerging technology. So I've been lucky enough in my career to kind of live through three, let's call them three large technological changes. One is the shift from basically paper based workflows to digitization across the organization. And in particular, I'm talking about, kind of the rise of desktop computing when we went from having paper based workflows, order forms, project management, et cetera, to fully digital on that side. And what were some of the threats that we observed there? And I've broken down these threats into kind of two categories, what we call first party risks, and then we're going to talk about third party risks. First party risks are really the changes that you're in control of. So, in the case of this first shift that I observed in my career, the shift to desktop computing, what we really saw was we saw the rise of something called vulnerabilities. Vulnerabilities just mean pieces of software that are vulnerable to attack. They have some fundamental flaw in the software that's typically in the way the software is written, or that's something like there's an included library, or if you're if you've been in the Windows ecosystem for a long time, you will have heard the word DLL. So something like that that has some fundamental flaw in it. And these vulnerabilities, when they first started to be cataloged, typically organizations would have already deployed hundreds of desktop computers or laptop computers across the organization. And so when they then go to turn on and see, like, hey, how many vulnerabilities do we have? The immediate report is massive, often tens, if not hundreds of thousands of vulnerabilities across the organization. So that's one of the first risks that I kind of observed in my career. Second, as we shifted into the second major shift in my career, and that's really the move to the internet and to the cloud, we started to see a new security model. And that security model is based not around, let's call it the network oriented perimeter that we had in that first wave of adopting desktop computing. In that first wave, our focus was to keep bad actors out of our networks. And so we did things like we had a lot of firewalls and we kept people out of our networks and we really locked down access and so on. But when we move to the cloud, that model changes dramatically. We move to a software defined network and software defined data centers. And what we find in the end is that misconfigurations become the number one problem. And similarly, when organizations went to churn on cloud security products for the first time, what they found was that the number of misconfigurations that they had was way higher than they anticipated. And we're going to talk about that in a little bit. And the third shift is the one that we're going through right now. And that is the fundamental change in application architecture and structures. We've moved away from monoliths, we've moved towards microservices, we've got a rise of APIs. But along with that, right now specifically, we've got the adoption of third party AI models. That could be large language models, generative AI, but that could also be using AI for business processing within a cloud provider environment, all of which is enabled by APIs and API connectivity. And so now we're facing this new risk of challenges around business logic attacks. And we're going to talk about that a little bit more in a minute when we analyze kind of the current state of API security. So that's the first party side. And by the way, this is not an exhaustive list of all of the risks. These are just some examples that I highlighted. with each technology adoption wave, there's actually multiple risks that come in there. Identity, for instance, has been a massive attack surface, especially in the shift to the cloud. So that's the first party side, the things that we are actively introducing through our use of those technologies and the things that we are ostensibly in control of. What about on the other side? What about attackers who are coming after us? Well, again, if you've been around for a little while, you probably have some experience with viruses, things like worms, things like kind of spam bots and so on. I specifically remember that the first virus I ever encountered and had to deal with was something called the Melissa or I love you virus, which was an email worm that just replicated itself thousands of times throughout the course of a day and just like filled up mail servers across the organization and made it impossible for people to send or receive email. And that came as the result of a virus sent by a third party that got into our environment, right? So that's an example of what we mean by third party risks. And as we've started to make that shift into moving our businesses online, one of the first types of attacks that we saw was something called the DDoS, distributed denial of service. And that just floods your website with so many requests that it effectively means that you are offline. Your site or your services are inaccessible to external parties. Similarly, as we started to put more data online, we saw the rise of bots and scraping. And really, the point that I highlight with both of these is that once you put things online, third parties have access to it and they do attack them. We found that, for instance, in our own API security lab in testing, when we put APIs online, they typically start getting traffic within 3 to 5 minutes. And that leads to really kind of the last point here that I'll say is that, across these right now, bots are getting smarter and smarter. And we're going to come back to that in a little bit. But really, those three risks around DDoS, scraping, and bots, these have increased both in velocity as well as in intensity and in terms of sophistication. So DDoS attacks are getting smarter, they're getting higher in amplitude, and they're also being more and more specifically targeted. Scraping is getting better. It's getting better at evading controls and protections that we might have from things like web application firewalls. Same goes for bots. Bots are getting much smarter in terms of the initial probing that they do of our networks and in terms of the follow-ups. And we're going to come back to that in a minute. So hopefully this helps, though, in kind of framing the two types of risks that we need to be aware of and how these risks have tended to play out historically in the adoption of new technology. The analogy that I like to use, though, is that we're very much in kind of a tortoise and the hare race situation. And how this really plays out in most organizations is that the business side, that could be business users, that could be software developers, tends to find a new technology first, tends to see a good use case or a good application for that, and they jump out ahead and they just go adopt it without the blessing of security. Security comes very much afterwards. And I kind of use this tortoise and the hare analogy because if you remember the analogy, what ends up happening is that the hare gets out to a massive lead, but the tortoise just keeps a slow and steady pace and then catches up with the hare over time. That tends to be true also in the adoption of new technologies. Software developers, for instance, may get way out ahead in terms of, let's say, cloud adoption, and then security has to chase after them. But security will eventually catch up and then apply policies and restrictions to cloud environments in order to bring a level of order and security to the environment. So that's kind of the analogy that I think of. And just for fun, I asked an AI to draw me a picture of security teams chasing developers down to bring things into control. And this is kind of what it got. And I just think it's like, first of all, a really hilarious picture because it's basically like 5, 6 copies of the same person. Effectively, every person working in either software development or security has that kind of beard look, has the same kind of hair color and pretty similar hairstyles. And, half of them wear glasses. And the mouths are just ridiculously off in this picture. But anyway, just for fun, I thought I would bring this in because, again, AI is kind of the focus of what we're thinking about right now. So let's talk briefly about the current state of API security, and then we'll get into the dual impacts and some of the implications, right? So APIs have been increasingly targeted by bad actors. The attacks have actually grown about 7x in the last year and a half. Well over 1 billion records breached at this point. And one really interesting point that I want to highlight is that through our own research, we've been tabulating all of the breaches over the last decade or more of data. what we see is that API breaches are roughly 1,000 times the size of the average data breach. So you can look at that IBM Security X-Force Cloud Threat Landscape report, and you'll find that 25,000 is the average number of records breached. But when you look at APIs, it tends to be more on the order of 25 million. And the main rationale for that is that when we look at API-based data breaches, they tend to be systemic flaws in the design of an API that make an entire data set open to probing and scraping and whatnot. Um, and as this is API Days Australia, I thought it would be really interesting to pull up a few select data points around Australia and Australian APIs. I think that third one is really the one to look at. APJ has the highest rate of API related attacks globally. So that is something to be really cognizant of. Attackers are actively targeting APIs in this region, in this part of the world. API vulnerabilities are already costing Australian businesses up to 2 billion a year. And exchange rates aside, that's US 2 billion, so quite a bit more in Aussie money. And what we see is that global bot related incidents are way up, and so there's a huge risk to any organization operating in APIs on the side of the world. Doesn't have to be the case, by the way. I mean, most of the challenges are relatively easy to overcome, and we'll talk about some strategies in just a little bit to close out the conversation. When we've looked at the types of events and the types of breaches that have happened, if we look by number of breaches, what we find is that authentication and authorization are pretty much in a dead heat for number one. So you would think that, okay, when we look at the number of records, they should be pretty similar. But in fact, that's not the case. Authorization shoots way up when we look at the primary attack vector for the number of records breached. So that's something to bear in mind, is that the impact of an authorization flaw can be much higher than the impact of an authentication flaw, although the two together is really the perfect storm of badness, so to speak. We're also entering an era where there is a new set of regulatory controls and compliance requirements around APIs. We saw our first case litigated in the US right now between the Federal Communications Commission, the FCC, and TracFone, which is a division of Verizon, one of the largest mobile carriers here. They entered into what's called a consent decree. And a consent decree is really an agreement between the carrier and the regulator, whereby the carrier says, like, hey, we messed up. We admit that we messed up. We're going to do better. And the regulator says, okay, you can stay in business provided you do the following things. And so there will typically be a set of prescribed actions, and there will be a time scale assigned to them. And so what they said here was follow the NIST 800-204 guidelines, as well as OWASP top 10 API security risks. One interesting thing coming off the back of that, though, and this is a piece of feedback we've been hearing for some time, was that when you look at those two things, first of all, neither of them is actually directly a compliance standard for APIs. NIST 800-204 does have some prescriptive controls and security requirements, but it's actually for microservices, and it's much more focused on, let's say, the API gateway or the load balancer layer, not the API itself. And the OWASP API top 10 is actually a set of risks. It's not a compliance standard. So it's very hard to measure. So to that end, I'm going to skip over this in the interest of time, but to that end, one of the pieces of feedback we heard from customers pretty consistently was we need something that is more prescriptive around APIs and API security. So we partnered with the Center for Internet Security, CIS, to come up with an API security guide. And so this is a set of more prescriptive controls and checks that you can apply. If you're interested, it's also an open community where feedback and collaboration is very much invited. The URL is on the screen there if you want to get more information, or if you want to join the initiative, please do so. All right, let's talk about AI for a second. A phrase gets thrown around right now that there is no AI without APIs, and it's actually very true. When we look at reference architectures for how to implement API initiatives within the context of an enterprise app, and I should be clear here, we're really talking about applications that integrate AI into fueling their productivity and their value. I'm not talking about a desktop user in their web browser sending questions to ChatGPT. That may be useful for that individual person, but the larger organizational impact will always come via these applications that integrate AI into them. Well, then the question becomes, how do they integrate AI? And when we look at the architecture, what we can find time and again is that there is no way to implement AI initiatives without APIs. Every single connection point, every single integration point is an API. And that will typically be, in fact, two APIs: the API of the AI provider that you are sending data to, and then there will be an API on your end that is doing things like sitting and receiving data or potentially passing data, et cetera. So that's why we say there is no AI without APIs. And in fact, all of the AI providers have recognized this, and some of the major announcements coming out of the organizations over the last 6 months plus are that they are opening up API calling capabilities broadly. We're going to talk about what that means and what some of those implications are as we continue to go. So let's get into the double edged sword. So AI tools are extremely powerful. And when we look at how they can have an impact on security, we see both positives and negatives. We see areas where AI can have a massive positive impact in terms of defending APIs, but we also see areas where AI can be abused and where the improper adoption of AI can introduce issues on its own, in fact, without the involvement of an attacker. So, what is AI good at? AI is good at a couple of different types of things. One thing to note is that AI is trained on a massive database of text. So we call this a corpus, and this is the basis for everything that AI knows. Because AI is often trained on a bunch of code, AI knows how to read code very well. So we look at things like static code analysis, and AI is quite good at that. And if we can, in fact, tell the AI which code is good and which code is bad, the AI can very often spot those differences. And if we give it even a little bit more guidance in terms of telling it, well, this is bad because it introduces this type of authorization flaw, then again, the AI gets very, very good at recognizing those patterns, misconfigurations, business logic flaws, authorization issues, etc. And so that's super helpful. We can now analyze code at scale very, very fast and with a high level of consistency. The second thing is incident summarization. APIs are kind of a funny thing because they very often, sit in front of an application. They sit on a network. They're connected to identities. They also talk to data stores at the back end. So when security teams are doing forensic or incident analysis around an API breach, they often have to check logs and data from all of those different things. They might need some application logs. They might need some database logs. They might need some network logs. They might need some identity logs, etc. Correlating all of those things together and providing a human readable summary of what actually happened is again something where an AI can provide a lot of value. So you can throw a bunch of logs at an AI and ask it to stitch together the story or the picture or maybe even the timeline about what went wrong. Other things, because of those data sets, if you throw a lot of logs at an AI over time, the AI gets very good at understanding what the patterns are, the expected patterns are, and it can do a good job of providing anomaly detection that can be indicative of attacks. And again, the more you can train the AI with historical data around when an actual attack has occurred, the better it will be. So that attack detection and predictive analysis, both of those things together based on the log flows is something that an AI can be much, much better and more scalable than a human at, right? But there are some limitations around this. So quite a few of the data breaches that we've tracked use something called the low and slow technique, where let's say they're not blasting an API with a ton of data exfiltration all at once. Similarly, lateral movement within a network. These are things that are often hard for an AI to pick up if they are not done in an anomalous type of way. And what we're seeing is that quite a lot of the API breaches actually look like normal API traffic. So that type of breach detection may not always work. Second, authorization based attacks. So figuring out who should or should not have access to a piece of data often relies on understanding a permission system that an AI may not be very good at. And then last but not least is like true anomalies. So things that are kind of false positive on the anomaly scale. Think of something like I have a user of a particular application who has always used the application from the US, but then gets on a plane, flies to Australia, and then wants to order a ride off of Uber or order food delivery or buy tickets to local events through a global ticketing platform like Ticketmaster or something like that. that is a legitimate first time use case in that IP address range, in that geography. And very often, if you use anomaly detection, that will always come up as an anomaly, as it rightfully should, but an AI may block that as a false positive. Awesome. So let's talk about some of the negatives. Well, one of the negatives here, in fact, is not necessarily a negative, but it's just a reality. And that is that, again, because AI is trained on a lot of code, it becomes pretty easy for any user to describe to an AI what kind of code they want. Please write me an application that does this, right? So, here, as an example, write me an application to create, read, update, and delete users over an API. And the app will do that. That sounds great, but that means that you may end up with this massive proliferation of AI based APIs. We already know that organizations are not great at having visibility onto all of their APIs. And if we now have the ability to have 10x or 100x the number of APIs on a network, that might prevent a challenge. Another challenge that we see is that code written either with or by AI tooling is often less secure than human written code. So, again, going back to some of the examples, when we think about things that could go wrong in there, that's things like permission systems, authorization checks, etc. But in fact, the research highlights that there are other things as well. Also, your AI provider that you integrate with might introduce some vulnerabilities into your application. I've just highlighted here that ChatGPT, in a recent analysis done by Axios, this is a third party that checks out services, actually only rated it, ChatGPT, 3 stars out of 5 in terms of security, 48% on the privacy scale, and only 2 out of 5 on the kid safety scale. So, just the adoption of an AI service may bring some inherent risk from the provider itself. Similarly, as we made the shift to the cloud, we made all kinds of mistakes in terms of leaving data open to the public. We are repeating some of those mistakes with new data services that we're using to feed data to AI models. So here's a recent example from the Google Cloud Platform Document AI service. And this is really, something called transitive access abuse, but that really just means that there was a very easy way for unauthorized users to gain access to proprietary data that was being put into that service. Also, any new technology gets targeted by bad actors who find ways to abuse it without the organization's knowledge or understanding. We saw this with the rise of cryptocurrency. One of the top hacks on cloud environments over the last 5+ years at this point is crypto mining. And what ends up tending to happen is that speed to adoption leads to kind of careless behavior. So in this case, for instance, it led to the leak of an API key that was able to be used to compromise and gain access to the customer's cloud environment that allowed the bad actors to load an LLM onto the API. In this case, it happened to load a sex chat API service, and the customer whose account was breached ended up paying for this service, right? Because the AI based application, this chatbot, was loaded into the customer's environment. And then AI may be used to query and attack APIs. AIs are now able to learn how to use APIs with just API documentation, which is typically very available online. And if an AI can learn how to how to use something, it can very often, with a little bit of prompt engineering and a little bit of kind of like prompt manipulation, be prompted to try to scrape all the data from an API. And in fact, we've seen examples of where AIs are being given looser set of instructions that will prompt them to try to figure out ways to break into environments. This is a recent example abusing the Docker API to break into a container. And so we've seen some of these already happen in the real world, and that will likely continue to happen. So these are some of the downsides and some of the threats that we're seeing. In addition, I mentioned that we would talk about AI powered adversaries. As I said, all of our APIs and testing environments actually get traffic within 3 to 5 minutes. We call that reconnaissance, typically, just looking for challenges in the environment. That typically leads to a little bit smarter follow up calls, looking for vulnerabilities. Now, if you combine vulnerabilities with an AI's ability to figure out, oh, okay, this vulnerability is breachable using this type of payload, well, the AI can actually go ahead and write that payload, bypass authentication, et cetera, et cetera. So I won't go through all of this, but I think the point is already pretty well made with just those first three items on this slide here. This is why, for instance, the some of the leading analysts are already warning organizations, hey, if you're in the process of adopting AI, you really need to pay attention to API security. This is a direct quote from Forrester from the API security landscape of Q3 2024. It is not just a technical requirement. Actually, API security enables business outcomes. What you are trying to do is actually successfully get benefits from this, right? Okay, I'm going to go quickly through threat modeling in an age of AI because actually the threat model around APIs hasn't changed very much. But what's interesting to understand about this is that we do have a stronger rating around misconfiguration and inventory management. But again, going back to the number of records breached, we see that really the main touch points are authorization and authentication. And when we look at kind of like applying this threat model to an overall reference architecture here, as we're doing, what we see is that the vast majority of the risks kind of live on the server side. In practical sense, what that really means is that you need to build security into the design of your applications. And so we've realized that kind of if you focus a lot of your efforts around those three things highlighted in gray there, validation, sanitization of requests, and then strong authorization in addition to checking authentication, you can do a lot of good things in terms of protecting your environment. This is also very, very true when it comes to AI. So let's go back to what we talked about at the beginning. So, what's the net result of all of this in the security team outcome? What type of risks are we looking at? What we're actually looking at is first party risks combined with third party attack vectors. Just to take a kind of analogy on this, when we look at vulnerabilities, which have been a thing for 20 plus years now, customers are still overwhelmed by vulnerability reports. The mean time to remediation is still 180 days. But when we look at that AI powered adversary, the mean time to attack is now as low as 22 minutes. When we look at cloud, we can see that cloud customers have double the number of resources and 20% of resources have misconfigurations. We already are seeing cases of those misconfigurations leaving some of the data elements around AI open to the public as well. So we've got a lot of first party risk on that side, but you can be sure that these third party attackers will find that data quickly. And they're already assembling databases of open to the world resources that are easily accessible. And where we are today with APIs transitioning into the AI era. So teams don't know the number of their org's own APIs or the third party services consumed. They're getting scanned within 3 minutes. You can see where this is going, right? So we've got these first party risks through our own adoption of APIs and AI technology. We've got the AI equipped adversaries and all the things that they can do with that, with the rapid scanning, probing for vulnerabilities, using AIs to construct payloads to exploit those vulnerabilities, extract data from open resources, et cetera, et cetera. So that's the combination. So just as a quick takeaway, if you're thinking about how to secure your own company's AI journey and the APIs around it, focus on continuous discovery and visibility. Make sure that you've got some automated tooling that is continuously showing the security team all of the APIs in use, both our APIs as well as those of the third-party providers we're consuming. Best practice is to also get some observability in place that goes to a central audit trail so you can track the utilization. And then, of course, you want some assessment and policy enforcement around that. You want to understand of all of the things, the APIs, for instance, and the applications that are incorporating AI, how good are they or how poorly constructed are they from a security perspective? And then enforce some policy around them so maybe you don't have unacceptable risk to the organization. So hopefully that was helpful. For anybody watching this video after the event, I'm very open to taking your questions. You can just email me, jeremy@firetail.io. We also have this offer for you that does apply to people watching the video as well. We've got a free tier on the FireTail platform. If you're interested in testing it out for your own organization, we actually will double your free tier limit. So you'll get, I think, 2 million API calls a month as opposed to one, and you'll get 10 APIs instead of 5 that you can monitor and check out. This will also get you today's slides, as well as the State of API Security report that we referenced in this talk with some of those data and statistics, and a couple of other helpful things like that CIS API Security Guide. As I mentioned, just Jeremy at FireTail.io, or reach out to anybody on the team over here. We're more than happy to help and answer any questions that we have. And to you, we say thank you for the time. Thank you for checking this out. And to the API Days team, thank you for organizing. I've been Jeremy at FireTail. Bye bye.